Dear students, today we'll continue our practice on Mathematical Analysis 1, and the next topic is integration by parts, change of variables. Okay, first of all, let me explain integration by changing variables. So let's consider an example and it will be clear for you. So first example, exercise number 1. So here we have the following integral and we need to calculate this integral. So the integral x cubed 1 minus 5x squared 10th power. So we need to calculate this integral now, and by using the method of changing variables. Firstly, let's denote this 1 minus 5x squared, this one, by t. And this is variable, our new variable, t. And what does it mean? So it means we have, we need to find here x, for example. So if we want to find x, it will be tx, of course, here. 5x squared, this is 1 minus t. And now find dx also here, and here how to find t. So I mean x. So x squared is, in this case, it will be 1 minus t over 5. Yes, and then let's try to find dx. So dx is differential of this one. It will be 1 over 2, and this one 1 minus t over 5, and times minus 5 here, because it will be 1 over 5, it should be, and here minus 5, here minus 5. Let's put here minus and times 5. So then it's equal to minus dt, of course, then, because when we compute the dx, we need to put here which variable we will find the differential. So this is t, and it will be dt here. So now it is minus dt over 10. Minus dt over 10. I mean here not dt over 10 times this one also. 1 minus t over 5. And now when we here square root, of course, that's why this is equal to this one. So I compute for square root, but here I didn't write. So now and now if we find x times dx, so x dx, this is equal to this one times this one. Yes, they are cancelled. Look here. So this is square root 1 minus t over 5 times minus dt over 10 and times 1 minus t over 5. So they are cancelled, two ones, and we have just minus dt over 10. So this is our x dx, and now this is x dx, this one. And now let's try to find so our integral now. let's put, so look here, we have x dx. If we change our x dx by this one, we have just x squared and this one, and x squared, this is 1 minus t over 5. So now just put, instead of x squared, y minus t integral 1 minus t over 5 and times this bracket. So this is just t 10's power, and x dx we have also. So x dx, this is minus dt. So here I will put minus before our integral dt over 10. So now let's continue. And here we have integral. So look here. So this is 50, 1 over 50. And t 10s minus t 11s, or if you want to write t 11s minus t 10s dt, it will be again negative minus 1, multiplying minus 1 and 2 minuses, they give us plus. So this is just 1 over 50 t 11 minus t 10th degree. And now we can continue it, and here 1 over 50, and the first one, it is just t 12 over 12 minus t 11 over 11 plus c. Okay, and now if we continue, so we have the following one. Just put now, instead of t, our expression 1 minus 5x squared, this is our t, our new variable. So we need to change this t by this one, because we need to find with respect to x, not t. So 1 over 50 and 1 minus 5x squared 12th degree, and or we can find common denominator, simplifying this expression. I think it's clear. So minus t 11, so it means 1 minus 5x squared 11th degree over 11 plus c. You can simplify this expression and get the final answer. Okay, now let's consider the next example. So this is one. Let's do this one. Okay, so x fifth power, the integral x5 over 1 minus x squared in square root dx. Okay, now again we need to change our variable, and how? So look here, let's write in these square brackets of them 1 minus x squared in square root, let denote by t. So and here when you find t's, so just 1 minus x squared, now it will be t squared. Hence x squared is 1 minus t squared. So and now x is square root of 1 minus t squared. So now we can find dx here. Dx is 1 over 2 1 minus t squared and times 2t with minus this is the derivative of composite function. Okay, now they are cancelled, and look here, if we multiply by x. So again, we have here x dx. If you multiply by x, so they are cancelled. Look here. So they are again cancelled, and x dx over and we have just t. So our t is this one, 1 minus x squared. So x dx over 1 minus x squared, it gives us minus dt. Minus dt. Again, so here we have dx is this one. dt, of course, here we have. And if you want to find dt from this equation, it gives us this one. So now we can replace our variables to t, and we'll get the following one. So let's continue. And here we have minus because of this one, and here we have x fourth degree. It gives us x fourth degree just 1 minus t squared because this is x squared, and fourth degree, here we have just fourth degree because dt is equal to x dx over 1 minus x squared, and here we have just x fourth degree, and x fourth degree, it is 1 minus t squared because it's x squared. So, and now it dt, and let's open the brackets. So 1 minus 2t plus 2t squared, of course, and the plus t fourth dt. Okay, let's continue. And we have the next one. So it is minus, let's put minus, and the first one will be just t, then plus 2t cubed over 3, and plus t5 over 5 plus c. If we continue, so we have just putting instead of t this value, so 1 minus x squared in square root, so it will be minus we can take out all of this t, so we have, let's firstly do by t, it is 1 minus 2t squared over 3 and plus t fourth over 5, so plus c. And now if we replace t by our denotation, so we have minus 1 minus x squared, and then in the brackets it will be 1 minus, here we have squared, so it is just 1 minus x squared times 2, of course, over 3, and plus the last one is t fourth degree here, so it is this one. If it is fourth degree squared, it will be, so this is just 1 minus x squared over 5 and plus c. So this is final answer, but you can again simplify this expression and write your answer. And let's consider the next example. So here we have integral sine x times cosine cubed x over 1 plus cosine square x dx. So we need to find this integral. So here, again, we will use the changing variable. So substitution, the method of substitution. Here, so 1 plus cosine square x, let denote by t. Let denote by t. And now, So it means so we can use trigonometric formulas, or here find cosine square x, this is t minus 1. Cosine square x, it is t minus 1. And sine square x, it is 1 minus cosine square x. Yes? So we can find here also sine square x, it is sine square x, it is it is 1 minus t plus 1, 2 minus t, or let do like this. So here find dt. So in this case dt, it is d of cosine square x. Yes, so d1 plus cosine square x. So it is equal to 2 cosine x times minus sine x. So here minus sine x. So it means we can find here that let's continue here. So what we get here, and if you continue, we have cosine x times sine x from this equation. It's equal to dt over minus 2. Yes, dt over minus 2. Okay. And now let's put all of them to our integral. So integral sine x times cosine x gives us minus dt over 2. And we have just cosine square x. So cosine square x, this is this minus dt over 2, here minus, it's minus. So, and now t minus 1 over 1 plus cosine square x, this is just t and dt over 2. So here we have 2. And now we can write this integral like, if you multiply minus to t minus 1, we get 1 over 2 and 1 minus t over t dt. Or it's continued and we have 1 over 2, 1 over t minus 1 dt. And now this is equal to, the integral is now 1 over t, this is just natural logarithm of t, and the minus 1 over 2, it gives us minus 1 over 2 t plus c. And we can replace our variable and with 1 plus cosine square x, because we denote by t it, and we have 1 over 2 natural logarithm of 1 plus cosine square x, or we can write here now brackets because this is always positive, and minus 1 over 2 in brackets 1 plus cosine square x again, so then plus c. So this is final answer. Okay, now let's try to find the next example. So here we have the next one, exercise number 4 in our case. So it is dx over 1 square root of 1 plus e to the power of x. The following integral is given and we need to find this integral computed. So let's firstly again use the method of substitution here. let denote with t e the power of minus x over 2. If we denote it by this one, we get here the answer. And dt, it will be, dt is here minus 1 over 2 minus 1 over 2 and e the power of minus x over 2 dx. So this is our dt. And now we need to substitute our variable. So here we have this one, dx, and the square root of 1 plus e the power of x. If we continue this equation, so however e the power of minus x over 2 is t, we can write here dt, it's equal to minus 1 over 2t dx, yes? Or hence dx, it is 2 dt with minus over t, 2 dt over t. Okay, and now let's put our new variables to our integral, and what we have here. So dx, this is minus we have 2 dt over t times this one. So e the power of x, it is t minus second power. So it is 1 plus 1 over t squared. Okay, let's continue. Minus integral 2 dt t times, here we have okay, so we have like this, t squared plus 1 over t squared, and when we squaring this, when we take square root from t squared, we get t just, yes? So this is equal to, let's move to the left side, and here we have the next one. So okay, so it is minus integral 2 dt over, they are cancelled, look here, t and this t squared, and just t squared plus 1. And this is table integral, so with ln, natural logarithm, and this is equal to, from our table, minus 2 natural logarithm of t plus square root of t squared plus 1, and of course plus c. So that now we can replace our variable t with e the power of minus x over 2 with this one, and we get the following answer: minus 2 natural logarithm of here we have e the power of minus x over 2 plus square root of minus e the power of minus x over 2 plus 1 and plus c. Okay, now we can simplify this expression, and after simplifying, here we have again 1 over e the power of x over 2, so it will be e the power of x, and we can take out e the power of this x, then we have the next one, I think will be correct one, so x minus 2 natural logarithm of, after simplifying it, 1 plus e the power of x here, and plus 1. We need to divide, then factorize it. Okay, plus c. So this is final answer here. It's final answer. And now let's consider the next example. So the integral dx over 1 minus x squared, the power of 3 over 2. The power of 3 over 2. Okay, so what should we do firstly in this case? So remember, we can replace our variables with trigonometric functions. So for example, in this case, let x denote by sine t denote by x. So let's replace with sine t it is, and dx here is cosine t dt. Cosine t dt. Okay, now we can continue it. Why we need to replace this x with sine t? If we put here dx over 1 minus sine square t and the power of 3 over 2 here. Okay, so let's continue it, and the 1 minus sine square t gives us cosine square t, yes? And here of course dt we have dt. Here we have dx, we will change dt and times cosine t here. So what we get here, cosine t dt over cosine squared t times 3 over 2. Times 3 over 2. And now, so this is 1 minus the power of 1 minus 3 over 2. This is just squared we have, yes? Because this is cosine t, this is first power, 1 minus 3 over 2 now, and this is just 1. I mean 1 over 2 here, and we have just squared t, yes, cosine squared t we get just, and this is 1 dt over cosine squared t, just cosine squared t we have, and this is from our table again, it is tangent t plus c. And now we need to replace our t with x again, so this is t, it is arcsine x we have. If we want to find t from this equation, it will be arcsine x. So tangent arcsine x plus c. This is final answer. Let's consider the next example, exercise number 6. So here integral a square minus x square dx. Okay, let's do it now. So in this case, we need to replace our x as a sine t here, a sine t, and why? Because this is it will be useful for us when we compute this here. When we put here a sine t instead of x, we get a squared minus sine squared t, yes? We can find here cosine from this equation. So, and dx is a cosine t dt. This is dx. Okay, now let's continue and let's put to our integral. So we can define like this: a squared minus a squared sine t, sine square t of course, times a cosine t dt. And this is a square, we can factorize, and here write a 1 minus cosine 1 minus sine square t this now, and times a cosine t dt. So I think it's clear already. And here we have now a squared out of the integral, and it gives us cosine square t, but we have square root, and we get just cosine t and times cosine t, so we have cosine square t here and dt. So now, and how to compute the cosine square t, integral of cosine square t? We'll use the formula. So a squared integral 1 plus cosine 2t over 2, this is equal to this one, and hence we have a square over 2 integral 1 plus cosine 2t dt. Then if we continue it, so we'll get here a squared over 2 times t in brackets and cosine 2t, integral of cosine 2t, this is plus 1 over 2 sine 2t, 1 over 2 sine 2t, and then plus c of course. And now we can replace our t. So now t is arcsine x over a. Here t is arcsine x over a. Just put instead of t arcsine x over a everywhere. So we have a square over t times arcsine x over a in first case, then plus 1 over 2. So here sine 2 arcsine x over a and plus c. And we can here also simplify using the trigonometric formulas and they get the final answer. I think it's clear. And now let's move to the next method, integration by parts. So here let me firstly explain what is this method of integration by parts. So if functions u and v are differentiable, and for u times v prime there exists primitive of this function, for this function, then the integral of u dv equals to uv minus integral v du. So this is what we call the integration by parts. So we can divide our integral to such kind of parts like u and v, and then using this u and v find the value of integral. For example, let's consider any example. So exercise number 1. Find integral x natural logarithm of x dx. So with using integration by parts, it will be very easy to compute this integral. So putting u as natural logarithm of x, and here we have v, look here, u dv, yes, so then dv is now x and dx here, the other ones, yes. We take as u the function natural logarithm of x, and then our dv will be x dx, because the form should be u dv in this form. So now let's find du here. Du, this is differential of u, because we need du here. And this is 1 over x dx. 1 over x dx, and here we need to find, and this is integral of this x dx, yes, this is inverse operation to derivative. So this is x squared over 2, x squared over 2, this is v. And now, and let's continue. So here we have, let's put now to the formula, to this formula. So this is main formula for us now, integration by parts. So now we have this integral, and it is in the form u dv now, and this is equal to uv. U, it is ln natural logarithm of x, times v. It is x squared over 2. So x squared over 2 natural logarithm of x. Now minus, in the middle we have minus integral v du. So v is again x squared over 2, du, it is 1 over x, times 1 over x dx. So they are cancelled, and we have x over 2. So if we continue, it will be x squared over 2 natural logarithm of x minus, so we have just x over 2. Now it will be integral of x over 2. This is x squared over 4 plus c. This is final answer. Okay, let's consider the next example. So here we have with number e the power of x. So e the power of x times cosine x dx. So here what we get, so e the power of x is just u, let's denote it by u. E the power of x by u. So then cosine x dx, this is dv. This is dv. So du is e the power of x dx again. And now here v is cosine x here, sine x, because integral of cosine x, this is sine x. And now sometimes we get the integral of tabular form. So in this case we have the following one. So if you put, it will be repeating, so uv, so u times v, it is e the power of x times sine x minus integral of v du. So v, it is sine x, e the power of x sine x dx. But now We will do it one more time. And if we do it one more time, we get the given one, e to the power of x cosine x, and then we can find with equation this value of our integral. And let's continue. So again, now e to the power of x is u, and the sine x dx, this is dv, hence du is e to the power of x dx, and v is cosine x now. Okay, so then we have e to the power of x sine x minus, so let's open now this integral by integration by parts. So here we have e to the power of x times cosine x, and the minus it will be here minus cosine x, of course. So this is plus now, it will be plus. And here we have minus, and in the formula we have again minus, so this is plus now, plus integral e to the power of x cosine x dx. So look here, they are same ones, e to the power of x cosine x dx and e to the power of x cosine dx. So what we have here, so this integral equals to this one. So using this equation, we get here minus, we have of course here minus, I said minus but put plus because we have 3 minuses and it gives us plus. So now if we move it to the left side, we have 2, hence 2 integral e to the power of x cosine x dx equals to this one, yeah, e to the power of x sine x plus cosine x, sine x plus cosine x, and then we get the integral, if we divide by 2, e to the power of x cosine x dx equals to e to the power of x sine x plus cosine x over 2. This is final answer, plus c of course, because here we have plus c, and c over 2 it doesn't matter, so this is all again constant over 2. And let's do the next example. So find the integral x squared arc cosine x dx. So we'll do it with method of integration by parts. So here in our case, this arc cosine x will be u, and x squared dx is dv. Hence, du it is 1 over square root of 1 minus x squared. 1 over 1 minus x squared, and v is x cubed over 3. And now let's continue. So let's use the formula uv, it is arc cosine x times v it is x cubed over 3, minus integral v du. So v it is x cubed over 3, so 1 over 3 x cubed dx, here dx of course, dx over du, it is dx over 1 minus x squared. Okay, now we'll use it again, or we can do without using the okay, so this is x cubed over 3 arc cosine x, and then minus 1 over 3. We can write this one x cubed dx as, so this one is 1 minus 1 over 1 minus x squared. We can write in differential. So this is also the same with integration by parts, because if we want to write in differential this one, it will be now x squared, because here we have 1 over 1 minus x squared. Differential, it will be it is differential of 1 minus x squared in square root over x. We need to divide by x, and here we have x squared times d and square root of 1 minus x squared. This one we will get. So, and now this is x. So this is our new v, this is our new u. So now we will use one more time the formula, and what we get here, x cubed over 3 arc cosine x, then minus here uv, yes, so uv, it will be x squared times 1 minus x squared over 3, and minus 2 times minus will be plus integral. So now v du, so v is 1 minus x squared times du is or we can write like this, 2 dx squared. Yes, this is du, however u is x squared. So we can just find like this, or just using the differential define our u and v here. So in our case it's very useful for us if you write in differential. So it dx squared now, and now our variable, it depends on only x squared, not x. So we can easily find here by x squared our integral. So if we continue, it will be arc cosine x, then minus x squared 1 minus x squared over 3, and this integral is, now it's just power function. So 1 minus x squared in the power of 2. Yes, because we can add here 1 minus, we can add this one, because this is 1 minus x squared, it gives us again gx squared. They equal, so they are equal. That's why we have 1 minus x squared, and here also in differential 1 minus x squared. From previous lessons, it will be just 1 minus x squared, 1 over second degree, and this is, so it's just power function. Minus here, because here we have minus 1 minus x squared, which powers? 1 over 2 plus 1, 3 over 2. 3 over 2. So this is cubed, and that's all. 3 over 2, and then over 3 over 2. Here, of course, 1 over 3 we have, because before of our integral 1 over 3, so it means we need to multiply 1 over 3 both of them. So here 1 over 3 and 3 over 2 plus c, or this x cubed over 3 arc cosine x minus x squared 1 minus x squared square root of 3 minus 2 over 9 square root of 1 minus x squared cubed plus c. This is final answer. And let's do the next example. So exercise number 4. So here we have the following integral. Find arc sine square x dx. Okay, so here, so the u is just arc sine square x, and dx it is dv. Hence we have as du it is 2 arc sine x times times here sine square x, yes, times 1 over 1 minus x squared. This is differential of arc sine square x, and now v is x from this equation. V is x. So let's continue, and so what we get here, so the arc sine, let's put to the formula uv, so x times arc sine square x uv minus v du. So v is x over 1 minus x squared times 2x arc sine x dx. Here dx also we have. So now so what we get here, okay, so it will be again x arc sine. I think we need to one more time use the integration by parts. So sine square x, then we can do like this. So this is okay, so x over, again, yeah, we did this kind of work in our previous example. So minus 2 integral arc sine x, and this one gives us in differential d square root of 1 minus x squared. Okay, so if we find differential of this function, we get this one, and then dx, the dx is now this one, and let's continue it. So we need to use one more time integration by parts, and we have the next function. So x arc sine square x plus, so now it will be plus because the so in the middle it will be plus because the differential will be with minus, so here will be plus. So here will be plus, and now it is this is also plus now, yes, not minus. Here it will be plus arc sine square x plus 2 uv, so arc sine x times this one, 1 minus x squared times arc sine x, and what do we get here? So this is arc sine x times this one, and in the integral we have now v du. So our v is this one, our du is now just differential of our arc sine x. This is 1 over 1 minus x square root of 1 minus x squared. They are cancelled. The differential of this one, d arc sine x, it is 1 over 1 minus x squared. So it means when we compute here, when we write here minus v du, so v is square root of 1 minus x squared times du, so du is now this one, they are cancelled, dx, and so of course here we have 2 because we need to multiply 2, and we have just 2 dx in the integral. Yes, so it is now x arc sine square x plus 2 1 minus x squared times arc sine x minus now 2x plus c. This is final answer. So we will use these methods in the next lessons also, when we compute the integrals of rational and irrational functions. So I think it's clear with this method. Today we started two methods, method of substitution and method of integration by parts. If you have any questions, you can contact with us in discussion group or in the Didactica portal. So the next time we'll continue the topic integrals. Thank you for your attention.